Hey everyone, we will be working with number 5 today, and number 5 tells us that the ratio of the interior angles of an m-gon and an n-gon is 5:4 respectively. So we want to find all values of m and n in the form of an ordered pair m, n, such that m is greater than n. So m is going to be the bigger polygon, and it's going to be the smaller. So a formula to represent the sum of the interior angles of a polygon looks something like this. 180 times the quantity x minus 2. And if you think about that, x is the number of angles. So let's say a triangle. So 3 minus 2 would be 1 times 180. That's 180 degrees. And that is true for every triangle. Or a quadrilateral, 4 minus 2, 2 times 180 is 360, 360 degrees in every quadrilateral. So we know that the ratio is 5:4, or 5 divided by 4. And rather than all of the interior angles, we want to compare just one angle for the m-gon to one angle for the n-gon. So for that, this takes into consideration all angles. So we need to divide it by the number of angles, which is x, and that will represent the number of angles in the m-gon, because I'm considering this to be a proportion, so it's corresponding to the 5. And for the n-gon angles, that would be 180 times y, let's say, minus 2, all over y. Alright, so we have a 180 over 180, so we can cross those out, that'll be 1. And then, if we're treating this as a proportion, we can cross multiply this whole thing, right? Denominator, and this is the entire numerator. This will be entire denominator, numerator. So we would get 4 times the quantity x minus 2 all over x equals 5 times the quantity y minus 2. It's writing a 2 there. All over y. Now to get rid of these denominators, I'm going to multiply by the least common denominator, LCD, xy. So we got an x over an x here, so those x's would cancel and we'd be left with the y. That's quantity x minus 2. And similarly here, the y's would cancel and we'd get 5x times y minus 2. Distributing those, 4xy minus 8y equals 5xy minus 10x, alright? And then subtracting this 4xy from both sides, got some nice algebra going on here. Negative 8y equals xy minus 10x. That's an x, by the way. If we make this positive 8y, we'd switch these signs. And let's divide everything by 8, so it's solved for y, at least on one side, right? So that would be, and these both have an x term, so I'm just going to pull that out. X times 10 minus the x, or sorry, y, because we pulled that x out, all over 8. That's a kind of nicer form for that. Alright, so we want to test this equation, and because we need them to be the number of angles in the polygons, we need to get whole integer numbers. So based on this, testing y's is really easier than testing x's. So I'm just going to test the y's, and I have it set up here. Looking at it, we know 10 minus 10 for y would give us 0 on this side of the equation, and, well, 10 for y on this side of the equation, so that's not true, not going to work. And anything greater than 10 for the number of angles will give us a negative on this side, which means x would be a negative number of angles. That doesn't make sense. So we're limited to this range of y values. So let's just try plugging them in. 3 in for y. 10 minus y is 7. 7x times 8. So then x would be 3 times 8 over 7. 24 over 7. Not a whole number. 4 would be 6 over 8. So 4 times 8 over 6 would be 32 over 6. Nope. 5 over 8. That'll work. That'll just be 8. Right. 6 for y. And we'd get 4 over 8, which is 1 over 2. And y being 6, x would be 12. All right. Staying with me. 7 would be 10 minus 7, 3 over 8. 7 on this side, 7 times 8 is 56 over 3. And our divisibility rule for 3, adding up the two digits of the number, have to be divisible by 3. 5 plus 6 is 11. So that's not divisible by 3, not going to work. 8 for y is 10 minus 8, which is 2 over 8, which is 1 over 4. So 8 times 4 is 32, and that would work for our x. And 9, 1 over 8, that's going to work. That's 8 times 9, which is 72. So we want this in an ordered pair form for each of these. So this is, I guess you can consider this m and n, right? So our m's and n's in ordered pair form would look like this: 8, 5, 12, 6, 32, 8, and 72, 9. And those are our possibilities, with m being greater than n for the ratio 5 to 4 for the interior angles. All right, there it is. Hope you could follow that pretty well, and my slanted writing wasn't too much for you. All right. See you around. One more to go, huh? All right.